All right, that should be us. Hopefully we are now live and everyone can see us on the stream. Sorry for the delay, folks. Last minute setup issues there, but hopefully you're all with us and ready to get into some excellent talks tonight. I'll just give it a couple of seconds to kick in and everyone to let me know that it's all working. I can see the stream health building up. Okay. Get our viewers going. Yay. Okay. I think we're starting to get people in and watching. That's good. And anyway, when they join, they'll be on the slightly buffered version, but we want to make sure that we get everyone in and being able to ask questions. So usually try and give everyone a bit of a lead time. Okay, I think that's been enough time. Let's get into the preamble tonight. I will just start sharing our usual run deck and get everyone going. You need the big changes. Thanks, Greg. All good. All right, everyone. Let's crack into it. So, welcome. This is BrisJS. Woo! We've got 11 concurrent viewers and climbing. Thank you very much, everyone. That's good confirmation for me. So welcome. Yes, we've made it to another month, and we've made it through all the weird scheduling of April. Easter tends to muck it up a little bit, and then we had a bit of scheduling conflict. But we're here now. We're good. We can do this thing, and we've got some awesome speakers for you tonight. So thank you very much for tuning in with us and bearing with all the setup nonsense. Now, Slido.com is where you can get involved. If you're not a regular with us, you'll know that when we transition to our live streams, we have been using Slido to give you a voice, give you that ability to get feedback and Q&A with all of our speakers here. I act as a bit of MC there and relay your questions at the end of their presentation. So feel free to leave as many questions as often and as immediately as you like. Make sure you can hop on there and let everyone know what you're after, and our speakers will be able to answer. I'll also monitor the YouTube live chat if you can't reach Slido for any reason, and I'll try and sort of bridge them and put them into Slido so that we can collate them through there. But any which way, I will try and keep up to date and make sure that your questions and feedback go to our speakers. Okay, let's get into it. So yeah, we're still all distributed. So it's still really important to acknowledge the traditional owners of the site on which we broadcast from today, which is the Yugara and Bundjalung people. And I'd also like to pay my respects to elders past and present. Meetup, if you're not aware, we still use that for all of our announcements, and that way you can keep up to date with RSVPing for schedule changes. And I also use that to be able to send you out all emails as we get into the week before the meetup, just to make sure that we've got the latest in the schedule. If you're, and as we'll get to, if you're ever interested in trying to figure out who's coming up next, you want to get that keen eye on exactly what's being scheduled, please check out our GitHub issues, which I'll talk about in a minute. If you're not aware, we do have a code of conduct. You can find that at our site, brisjs.org conduct. That we're all online now, so that includes online. It's a harassment-free experience, everyone. So please be kind to others. Very important to me and hopefully important to you. We want presenters. So if you're in any way, thank you, Robert. Yatla represent. That's right. You know, you remembered. It's kind of you. Yes, if you're in any way inclined, please do shout out to be a presenter. We need you. You are what keeps BrisJS alive. And we love being able to take talks from anyone from anywhere, especially now that we're online. So it's not so Brisbane focused if you wanted to participate. If you, for example, in the past, you could never make it, timing never really worked out when we were having an in-person event. Now is your chance. You can come and attend BrisJS through our live streams. Hopefully everyone's enjoying the fact that you can get these streamed immediately straight to you. So please do submit a talk to us. You can do that through the present link on brisjs.org. I also like to tweet out a please present with us kind of link. I'll send that out after this little preamble as well. But we just handle that whole scheduling thing through our GitHub issues, and we use a series of tags and milestones to be able to make sure we work out who's coming up next. If you're hesitant and you're like, hey, I'd still like to learn about a particular topic, it's been driving me nuts, or maybe it's something that's in the zeitgeist that you really want to get into, but you don't have any of that knowledge on hand to be able to do your own talk, maybe just request a talk. You can leave a request for a talk on the GitHub issues as well, and that way we can try and source some of that from the community, and those appear on our website as suggestions. So if anyone doesn't know what to talk about, but they'd love to give a talk to everyone and give back to the community, it can be inspiration for other people. So hopefully it works both ways. This is an example of that BrisJS issue board. That's a screenshot from a while ago, but the concept is as you appear. So there we go. It's got some taglines for the length, for whether or not it's the candidate for the next one, and whether or not it's been volunteered or it's a request. So we've got a couple of different ones in there, and we tag it with a milestone as it's scheduled into each month. As you know, there's probably a few different social groups you want to keep on top of. Twitter is by far the most active one, but there's definitely a presence on Facebook if you want to follow that one. I like to try and at least match what I'm tweeting, but it's been a bit hard to maintain those two. I need to automate that a little bit. Then YouTube, you're on YouTube right now. So we've got a nice back catalog of our live streams here as well. And keep up to date with that one. If you're a subscriber, please subscribe if you're not. And if you're a subscriber, you will get the notifications when one of them has been scheduled as well. So that's super handy. That way you can see what's coming up. BrisJS.org. It's a nice little centralized place. It needs a bit of love, but it's definitely there to try and pull together the different links that I've been talking about today. And one of those is also the jobs view of our GitHub issues. So we also use our GitHub issues to be able to post a job. For example, if you're in your workplace and they've said, hey, try and spread the word. This is a way to do it within your local community. So it presents as a lovely long list of posts. There's a whole bunch of them in there right now that we've been getting a few through. There's definitely a few new ones that have been coming up, and they're fairly successful as well. So even just through our GitHub issues before it gets tagged properly to appear on the website, we've had a whole bunch of people jump on that, which is really positive. So thank you very much for engaging with that. And hopefully you can continue to find gainful employment or find folks in the community, which is getting harder and harder. And the competition is fierce, and we definitely want all the awesome devs working with us. Now, BrisJS couldn't happen without our community sponsors. And in the past, we've had a whole bunch of different sponsorships for our drinks and food and our venue and all sorts of different things, store prizes. The main one we really need sponsorship one with right now is our Zoom Pro subscription. So thank you very much. I work at PCCW Global. And they have been sponsoring our Zoom Pro subscription as we've moved into the live stream space. That helps us bounce our video feed directly to YouTube and gives us the ability to bring our speakers on and talk to us. Now, we're hiring as well, of course. There's a ton of actual positions at PCCW Global in Brisbane and beyond. This position that I'm going to talk to you about is with me. It's a team that we're trying to create. It's a brand new team, and we're super excited about it. So you can see this face on Zoom more often if you like, and come work with us. We'd love to have your input. We're after some seniors or mid-JS web devs, back-end or front-end, full stack, wherever you sit about that, we'd love to hear from you. Feel free to reach out to me. And the post for this position is, of course, on the BrisJS jobs board. So please check that. Tonight, we're getting into it. So we've mixed up the order a little bit. Just before we were going live, we're going to have Melissa up first, which is awesome. She's going to be telling us all about JavaScript in the cloud, and I'm super keen to hear that one. And the venerable Ashley is also back. Now he's going to be telling us all about building with microservices on Node.js as well. So that one's awesome, also really cool. Yeah, there's an awesome door prize as well. So Ashley's been trying to give away his brand new book on the same topic, building microservices with Node.js. And he's been very kind to be able to extend a couple of download voucher links so you can get your own copy of the book. And he's going to try and give away some physical copies as well. We're going to work out how to do that. So if you've been looking at our live streams in the last few months, you know that Wallaby has been giving a door prize like that as well. So this month we're featuring Ashley's book as the door prize. So if you don't know how this works, I'm going to use Slido to put a poll question in there. It's a short answer question. All you got to do is answer the question and leave your name and email address so that I can actually send you the prize when you win. Please feel free to get on there and answer that. That will start to come up within the first few minutes of Ashley's talk, and that way, it's relevant and everyone knows and everyone's been paying attention. So it's kind of a have you been paying attention quiz. So if you answer the question, should be a very simple one, you will be in the running to get one of these great, Pact Publishing? Manning Publishing downloads of Ashley's new book. And so we'll crack straight into it. Let me stop my share here and get back to my face. And I would like everyone to be introduced to Melissa. Melissa, are you there?
Hello.
Hi, welcome. Thank you very much for joining us here at BrisJS. Like I was saying, we were starting to get more folks from abroad, and so hi from Brisbane, all the way down in Melbourne.
Yeah, that's right. Thanks for having me today. It's good to virtually be over in Brisbane.
It's a pleasure, and I will stop my video and let you take it away.
Cool. I will start sharing my screen. Cool. Cool. So can you see my screen, hopefully? I guess the live stream is a bit delayed, so hopefully we can see that there.
Yeah, you absolutely can.
Cool.
All good.
Awesome. Cool. Well, hi, everyone. So my name is Melissa Houghton, and I'm a lead consultant at Telstra Purple based over in Melbourne. And my socials are up on the screen. So if you'd like to connect with me in some way, Twitter, LinkedIn, or whatnot, please, feel free to reach out on there. So I'm an application developer, and I mostly work with both Angular and .NET. Some mix of JavaScript and TypeScript and otherwise. But I've also been learning a lot recently about cloud computing, specifically in Azure with a tiny little bit of AWS as well. But throughout my learning, I was really surprised with how much you could actually do with JavaScript in the cloud. So I decided to put together this talk for all of you. So what is the cloud? When people first hear about the cloud, especially if they're not involved in the tech world, they think of maybe the Dropbox or Google Cloud or something like that, but they're not quite sure what it means. But really, the cloud is software and services that run on the internet instead of locally on your computer. It's a server somewhere else, usually in a big data center. And the concept that cloud providers give us, such as Azure, AWS, and Google Cloud, is that you can rent the space and only pay for what you use, which makes it really easy to scale as your business needs change. And they manage the physical infrastructure for you. So it's like renting a house or renting a piece of land, depending on which type of cloud computing you're working with. And they give you different levels of control over managing the property. So really, there is no cloud. It's just someone else's computer. And as we know in BrisJS, probably familiar with JavaScript, but JavaScript is a scripting language that allows you to implement complex features on the web. And my first experience working with JavaScript was during one of my first jobs in university. I didn't learn any JavaScript whatsoever during my degree, but I started this internship and was told we were going to be doing web development in the main stack. So Mongo, Express, AngularJS at the time, and Node, all JavaScript frameworks. And I was handed this book, JavaScript, the definitive guide, to help learn JavaScript, and partnered with a senior to do web development. And from there, I've been using JavaScript throughout my career, focusing really on the front end and web development to create web apps. And traditionally, it is the language of the web. JavaScript was created in 1995 in just 10 days by Brendan Eich, who worked for Netscape. And he created it as a scripting tool to manipulate web pages in the Netscape Navigator browser. Soon after, it was standardized and took off to become the most popular client-side programming language, where today 97% of the web uses it. However, JavaScript is much more than just a client-side programming language. Scott Hanselman, who is a partner program manager at Microsoft, even went so far as to say that he proposes that JavaScript is like an operating system. And this quote comes from his talk, JavaScript, the Cloud, and the Rise of the New Virtual Machine, which I'll share a link to at the end. And I would highly recommend checking it out because he does some really cool demos on things that you can do with JavaScript. But what he was getting at was that JavaScript has a lot of the same characteristics that you find in an operating system. So it's a very, very powerful tool and language to use. So therefore, it really makes sense for us to be using JavaScript in the cloud. And JavaScript was initially created to also be used on the server side. It didn't become popular until Node.js came out in 2009 as a server-side language for JavaScript. But with the advent of Node.js for using JavaScript on the server side, it really opened us up with the ability to use JavaScript in the cloud. And today, if you look at the major cloud platform providers, JavaScript is supported on Azure, AWS, and Google Cloud. And in the words of Scott Hanselman, the cloud doesn't care about your language of choice. And if you're looking to develop JavaScript in the cloud, there's some really awesome tools and guides out there to help you get started. JavaScript IDEs such as Visual Studio Code and WebStorm have extensions that let you really easily integrate with your favorite cloud providers. And those extensions provide you access to quick start templates, ways to write, test, and deploy your applications fully from within the IDE. And so it makes it really nice to get started with cloud development using IDEs and languages that you're already familiar with. The providers also have a really big suite of SDKs available completely in JavaScript so that you can connect to their different services all within your JavaScript application without having to change what language you're using. So let's take a look at some of the cool things that you can do with JavaScript in the cloud. Cool. So let me pull up my Visual Studio Code. So I've mostly been working with Azure, so all of my examples are going to be based in Azure today, but a lot of the same kind of stuff you can do, as I mentioned, with AWS or Google Cloud or whatever cloud provider you are using. So this that I have on the screen, this is an Azure function, which is a serverless solution in Azure. So that means that Azure takes care of provisioning the infrastructure for you and allows you to auto scale. And it's basically a piece of logic that's hosted in the cloud for you. And oftentimes you only build based on usage. So this example that we have here is what's called an HTTP trigger, which means when an HTTP call is executed, this function will execute and take care of whatever you want to have happen. So this is really simple. It's just printing out a message for us, but it's written in JavaScript. And so you could write as much complex logic or simple logic that you wanted to in JavaScript here. And AWS has Lambda functions that are serverless, and Google Cloud have what's called Cloud Functions. So what I have here is a function that was actually created using the Azure function in what's called extension. So it's called the core tool extension within Visual Studio Code. So this button here shows that I have Azure. I've already logged in and connected it to my my Azure instance. I can see this is the functions section. So we're looking at our Azure functions. Here I have my local projects, which show this index.js that we're looking at, HTTP trigger 1. And this one I've already deployed up onto the cloud. So this with the function app icon here shows that it's already up in the Azure cloud. And so we can interact with things that are on the cloud or things that we have locally, all from within Visual Studio Code. So if I want to say I want to test this out, I can go click F5 and it'll start running it for me. And once it starts running, we can execute the function locally to test it out to make sure that it's working as we expect. Cool. So it's running. Oops. Yeah, it's running. And we'll just say execute. So all the function was doing was just taking in a, it's going to do an HTTP request, takes in a body, we'll say BrisJS, and we will print out, and it'll print out the response saying it was successful, and it's saying, hello, BrisJS, it was executed successfully. And if we wanted to, say, create another trigger or another Azure function, we can do that really easily from here as well. So there's just a button here to create. You can select the different templates. So there's different types of triggers. You could have something on a timer to say process, maybe generate reports or kick off some system every night or something like that. But we're just going to do another trigger. When I set up the project, that's when I determine the language. So I've already set it to be JavaScript. I'm just going to use it as anonymous, which means anyone can access it, which isn't very good normally, but for demos, that's okay. And we'll see it creates another trigger for us here. And we can go back and look at the code, and it already has the code all set up. And so if we want to then publish this also to our cloud, our Azure cloud instance, we can still, again, do that from within Visual Studio just by clicking the deploy to function app. So the function app is the container for all your Azure functions. So you could create a new one from within here, or I'm just going to deploy to the existing one that I already have. And I'm going to say yes. And it's going to deploy, and soon we'll see a little spinning icon pop up here that says it is deploying. So there we go. So it's currently deploying it onto Azure, and so we'll be able to interact with it very shortly. While that's being deployed, I'm going to go ahead and say that I want to call this one just so that we can see what's happening. So I'm going to copy that function URL and open up a browser. There you go. So in my browser here, all I've done is just that HTTP call. We can refresh it. And it says it went successfully. So that's actually going out to Azure and hitting that function that we already set up. So I haven't written any code, and I'm already using JavaScript in the cloud really easily with these templates and these tools that are already integrated in the IDEs that we know and love. And our second one was deployed. So now I should be able to change this to 2 and have that also execute successfully. So real good. So that's just one example of something you can do. Another thing that is quite common is having your static web apps. So static web apps, you could have your full app in JavaScript. Maybe you have an Angular app or some sort of other front-end framework that you want to host on Azure. And they make that simple to do as well using this static web apps feature. So here I am in the Azure portal, which is where you can interact with all your different cloud features. And I'm going to click on static web apps. If you haven't looked at it before, it won't be in that first list, but you can always search for it here and it'll come up. So it says it's in preview because they're still sort of finalizing all the details with it. So it's basically in like a test kind of version. So it's not recommended to use it for production apps at the moment, but you can go ahead and play around with it and get started. So I'm going to create a new static web app within here using my subscription. I'll create a new resource group, say BrisJS demo. Call it whatever you want, enter. I'm just going to say BrisJS static web app. Oop. Or maybe it needs to be one name. Sorry. Cool. And because it's in preview, only certain regions are available. So the regions are where the data center is located, basically, where in the cloud it actually physically is, where the cloud physically is. But because it's preview, not all the locations are available. So I'm just going to choose one that's close. And then I have all of my code is on my GitHub. So I'm just going to connect it to my GitHub here. So it's already authorized. So it's connected to me. That's Melissa. So I'm going to say authorize. And it'll do auth integration. And so then all you have to do is choose, I'm going to say which organization you're working with, which repo you want to use, and which branch. And then it'll also ask you about the build presets. So I'm going to go, this is an Angular app that I'm working with. So I'm going to add that there. And the repo, if you look in the code, there's different locations for the app and the API. So I'm just going to type that in here. API and dist. And you don't always have to have an API. If you just have your front end code, it'll work just fine without that. And so what it's done behind the scenes is create a build file for us. So this is a YAML file, which is a templating language that's used by Azure to be able to deploy different things. And it's actually using behind the scenes GitHub Actions as well. So if you've learned about GitHub Actions recently, it's really nice integrations between Azure and GitHub. So you don't have to do anything with this, but it's nice that you can actually go in and see the code that's in there, and that'll actually check in this file to your repository as well, so that you have the deployment details as code. So we're going to say review and create. And it should come up. Cool. And we'll say create. Cool. So in just a short little bit, it'll create everything for us. Oh, here we go. Deployment's happening. But also, if you didn't want to do it within the Azure portal, you could have also done it still within your Visual Studio Code. So I have this section here under my Azure extension for static web apps as well. And if we refresh, we can already see that static web app we just created is already available to interact with in our code. So you can do it. There's multiple ways that you can interact with the cloud using your JavaScript apps. So it's complete. Going to here. And if we go to the GitHub Actions, it takes us directly to our repository on GitHub, where we can see that it is currently building. It's doing the build steps, build and deploy. I think it takes a couple minutes depending on how big your app is. But basically, once that deployment is complete, we'll be able to access it from this URL. The URL, because it's just a demo and all that, was just automatically generated. So it has a bit of a funny name, but you can change that later on. So once everything is done, you'll be able to see your static content here automatically. So you'll have a nice quick way to be able to deploy your static web apps. So that's finishing up building. So we can look at that in a second, but I think I'll probably jump back to my slides. The other things that you can do in the cloud are, integrating with those SDKs, as I mentioned. They are basically, client libraries to be able to interact with things such as IoT devices. You can create what's called digital twins. They have full applications to be able to do really advanced stuff where the services are hosted in the cloud, and you're interacting with it in JavaScript. So we've seen how you can create a serverless function in JavaScript, how you can deploy it really quickly using JavaScript dev tools that we're probably already familiar with. We have seen how you can really nicely host and quickly deploy your static website and integrate it within GitHub using GitHub Actions and the tools within Azure. And we've also heard that you can use SDKs to connect to different services. And there are many, many things that you can do with JavaScript in the cloud. I could probably go all night showing you examples of interacting with all the different services, but pretty much anything that you can do in the cloud, you can do with JavaScript, or have it integrate with your JavaScript applications really nicely. You can expand into machine learning, you can expand into AI and all different sorts of things. JavaScript is used in mobile development, game development, and robots. And if you go watch that talk by Scott Hanselman, you'll see some pretty awesome demos that he's done, including a complete implementation of Linux Pentium processor implemented in JavaScript, or compiling a C application in a JavaScript virtual machine, running in a browser, running on Windows. And there's a concept called the rule of least power from Tim Berners-Lee, who is the creator of the web, that suggests that choosing the least powerful language is suitable for a given purpose. And as a corollary to this rule, that's where we get Atwood's law, which states that any application that can be written in JavaScript will eventually be written in JavaScript. So I hope if you're not yet using JavaScript, especially in the cloud, that you start learning all the different things that you can do, because you can really go out and explore and integrate with all these different features. And if you are already using it, I hope you do continue to explore and look at all the tutorials and links that I share to see the really cool things you can do, because the opportunities with JavaScript are endless, especially when paired with the power of the cloud. So thank you, everybody. And if you scan this QR code on the screen, or you go to the bit.ly link at the bottom, you can get all the different tutorials and resources and guides to getting started with JavaScript on the cloud on all the different major cloud providers, and the link to the talk I mentioned as well from Scott Hanselman. So thank you very much.
That's awesome. Thank you so much. Woo! Fantastic. We need like a sound effects board. I need to work on that.
Yeah.
Just like recorded from one of our previous in-person events. That's fantastic. Thank you so much for running us through that. We do have a couple of questions in here,
Cool.
which is great. So let me read them out to you. I'll just. Okay. I'll just hit a button, and that's us side by side. Okay. So now there's no real order to these. If you were planning to migrate a vanilla JS app to become a serverless / cloud function style deployment, what kind of strategy would you apply to split it up? Now, that's a big question.
Yeah, so the serverless side of things would work well more for what you would have as your backend. So you can have your API side be serverless functions, depending on what the back end of your app is doing. Whereas the front end side of it, what's displaying the web pages and, making the website happen or whatever your app is doing, that would be more of the static website. So you can have a combination of that static website deployment that I showed, and then also have the serverless function as the back end of what's going on, like when you interact with the page.
Makes sense. That's that divorced client server style approach that you kind of, it's pretty traditional with a lot of the Node development world as well, right? So
yeah, exactly.
Yeah, it's pretty good.
Yeah.
Okay, second one is, are there any cloud function native framework or build kits that make this really smooth? Thanks.
Yeah, well, there's all kinds of, I guess, getting started templates, especially from Azure. Like, I haven't looked at too many for the other cloud providers, but Azure has whole libraries of, here's how to get started with, say, they have like a cognitive search feature within Azure, and they have a template for getting started with a JavaScript app that integrates with that cognitive search. So if you're using their cloud features and integrating in that way, there's all kinds of like templates and getting started things that you can find.
Cool. There's one more. I think this is just a general question. How do the serverless options compare? So I'm assuming across Azure, Google, AWS. Is there any real camp to go with for any particular reason? I'm sure like the baseline approach that you sort of were demonstrating is like host a particular thing and get it started. And I'm sure they can all do that. But do you know of any particular aspect here where it might attract certain folks to go one way or another?
Because I haven't looked too much into the other cloud providers, I can't really give a good give opinion on why one is better than the other. I think oftentimes it's just, what you're more familiar with, and, like I work more with enterprise clients because I'm a consultant. So they often already set up in, like Office 365 and have a whole lot of the Microsoft, environment around them. So then it's more natural to use, Azure ecosystem. That's the word I was looking for. Yeah, the Microsoft ecosystems. Then it's more natural to use Azure. But in terms of whether one option is better than other outside of that, I can't really comment.
Totally fine. No problem at all. Hey, look, it's hard enough digging into all of the wealth of options that one cloud provider gives us compared to looking into like the three big ones. There's one more that just came in. Is it easier to make a cloud-based app in microservices or a Node monolith?
Well, I'd say Ashley's talk is probably useful for that question. I mean, I always think microservices are much better than monoliths because they're easier to maintain, and you just update little bits along the way. So I definitely say microservices in any context for sure.
Makes sense. And back to the whole integration and picking a provider. I think also, as you demonstrated, the GitHub integration and all of the bits and pieces, it's kind of seamless and kind of automatic. I think there's a lot to be said for that reduced friction. If you're using those services, for example, and that makes sense for you, then I'd see no reason why you wouldn't pick that. That seems to make sense for me. Yeah, exactly. Sounds great. Cool. Okay, I think that rounds everything up. Is there any final words you want to shout out to the world?
Just thank you very much for having me.
It's our pleasure, and I'm sure everyone at home has been loving it. So thank you very much. Gonna give you another virtual broadcasted clap, and thank you very much. And we'll shoot your details through to everyone as well. Make sure that everyone can find you on the on the GitHub as well. You've got your post on there, and we can always get in touch through there as well. I've retweeted a bunch of your tweets as well, so check out the
Awesome.
BrisJS Twitter stream to find the handle in the posts that have come through from that. You can follow all of this cool microservices stuff around the web. Well, good. Thank you very much.
See ya.
And we'll introduce Ashley. See you later. Awesome. There he is. There's Ashley. Wow, no introduction necessary. How you doing, Ashley?
Yeah, good, thanks. Kevin, how are you?
Good, good. Getting through and presenting everything. And oh, look, another one through on the Slido. Thanks, Melissa. Awesome. Yeah, okay. So
Cool.
look, you're the regular friend of BrisJS now. We're
Always
gonna
happy
have
to be
start
here.
calling. Yeah, absolutely. I'm always happy to have you. So thanks very much. And
Cool.
look, I'm just going to get out of the way and let you take it away.
All right, thanks, Kevin. Thanks, Melissa, as well. That was a really cool first talk tonight. And I do have a few things to say about monoliths, as you might expect. So hi, everyone. Thanks for tuning in. My name is Ashley Davis. I'm super happy to be here again, talking for BrisJS. Tonight, I'm talking about building microservices with Node.js. Microservices, obviously, it's a pretty large topic, and I can talk about it for hours. So I have to be kind of strategic. And what I'm talking about tonight is actually going to be quite simple. I'm going to describe what microservices are, why you might want to use them. Ultimately, we're going to be using Docker to build, run, and publish our microservices. And that means we can use pretty much any programming language or technology stack. So we don't have to use Node.js or JavaScript to build microservices, but I do hope to convince you that Node.js, it is a really good choice for microservices. And, maybe not just because I'm a fan of JavaScript, it is actually a really good platform. I'm going to end this talk with a live demonstration. I really just want to bootstrap a quick, simple Node.js microservice from nothing. I just want to show you how simple it is to do that. And I'm even going to write a Docker file, and we're going to build an image. And we could deploy that image to production, but we're not going to quite go that far today. All right, I'm just going to get set up and share my screen. Okay, so first thing I want to say actually is this talk is actually, part of a bigger series of talks that I'm doing. So there is actually kind of like 3 parts to this. And this is kind of like part 1, but almost like a cut down version of part 1 as well. And if you look on my YouTube channel, I'll just show you that quickly. So my YouTube channel here is the Data Wrangler. You can see there's a playlist for this as well, but you can just see here up front, there's building microservices with Node.js part 1. That's basically this talk, except a little bit more detailed. Possibly a little bit more in the demo. We'll see how much time we've got tonight. But there's also a part 2 here as well. So if you want to go a little bit deeper tonight, we're just going to look at one microservice, which isn't much at all. But if you want to go deeper than that, jump straight in after this talk. Jump straight into building microservices with Node.js part 2, which is already on my YouTube channel, and that shows you how to scale up to multiple microservices in development using Docker Compose. And in a couple of weeks, I'm also going to have a part 3 up here as well, where we talk about deploying Node.js microservices to a production Kubernetes cluster. So again, this talk, I could go on for hours, and I do go on for hours, and you can kind of follow some of that on YouTube if you want later. Also, please feel free to reach out to me later, talk to me on Twitter or by email. You can see my details there up on every slide. I'll tell you a little bit about myself. Some of you probably know me quite well because I'm here so often. I'm the CTO of Sortle, and we're a company that has a product that basically helps you sort your digital assets through the magic of machine learning. I'm also the developer of DataForge Notebook, which is like Jupyter Notebook, but for JavaScript and TypeScript. So it allows you to kind of build your code, write your code interactively with live visualizations, and then later export your code so that you can run it in production. I'm also the author of 2 books with Manning. So my first book, Data Wrangling with JavaScript. Basically, the purpose of that book is to show you JavaScript developers that you don't necessarily need Python to work with data, and that everything you need is basically already included with JavaScript or any of the magical libraries on NPM. You don't necessarily need Python. You can do it all in JavaScript. And of course, my latest book is Bootstrapping Microservices. And the reason I'm talking about microservices tonight. So Bootstrapping Microservices, it's a practical and project-based guide to building applications with microservices using the latest tools like Docker, Kubernetes, and Terraform. Now, it's not, Node.js isn't central to this book in that, you can build microservices with any language or any runtime, kind of any technology stack that you want. But, I'm a JavaScript fan, obviously. So, all the examples in the book are in JavaScript and Node.js. So you guys listening in tonight at the JavaScript meetup will appreciate that, hopefully. So in this book, basically, I lead you through building from scratch a small but complete microservices application. Starting off just building a simple Node.js microservice like I'm going to show you in this talk tonight, and then scaling up to multiple microservices with Docker Compose, and then ultimately deploying your microservices to a Kubernetes cluster. And it leaves like no stone unturned. It kind of it walks you through the whole process, and so that you don't have to figure out anything really. It's just really good set of recipes that I use in production to build microservices applications. And of course, everything I'm talking about tonight is basically from the book. So what I'm talking about tonight is really from the kind of the early chapters of the book. And if you like what you're seeing or like what you're hearing tonight, you'll definitely find more of that in this book. And please hang about until the end. So we're going to do a book giveaway. I've got 2 copies of the ebook to give away. And for everyone else, I've got a discount code. Before we talk about microservices, now let's really look at the alternative, which is the thing that we call the monolith. That's kind of what came before microservices, although not really, because distributed applications have really been around for a long time. It's called monolithic because it's an entire application that runs in a single process. Traditionally, this is like, the most common approach really for developing servers and backends. It's still in common use today. Like people are still using monoliths. Obviously, it's not something that's gone away, and nor should it. It has its place. The typical wisdom is that it's easier to build a monolith than a microservices application. That's true to some extent, of course, but also I want to kind of challenge this notion that it's somehow easier to build a monolith than microservices, because I think with modern tools and good automation and a commitment to a simple architecture, microservices are easier and cheaper to build than ever before. So the choice of whether to go microservices or monolith, it's not quite as simple as it used to be. So what's so wrong with the monolith anyway that we want to kind of replace it with microservices? Now, there are some good reasons to use a monolith. I don't want to seem biased or completely biased towards microservices. Obviously, it can be easier to kind of get started building a monolith than it is with microservices. Monoliths require less technical skills. I mean, I think that's debatable, really. But anyway, starting with a monolith, it is a good way to start a new application, or a throwaway prototype, or to create an MVP, or to validate a new business model or something like that. And if you have an application that's never going to grow, it's never going to need the flexibility of microservices. You're not planning on evolving it over time. A monolith can be the right choice for that. So there's no one saying that monolith is always bad or always wrong. So don't take that away. But there are many problems with the monolith that will make you want to think more carefully about using it. A monolith will start very simple. Ultimately, like any modern application, though, it is going to grow. It's just destined to grow really complex, right? You can't hide from complexity by choosing to create a monolith. Just let me say that. Now, monoliths are very difficult to scale, both for scaling your development team and also for scaling the performance of your application. Monoliths are difficult to restructure, and that's something that gets worse over time. Monoliths have a really large deployment risk, and that's to say that when you update your monolith, if you break it, you break the whole thing and you leave your customers with nothing. So, that's how risky it can be to deploy anything to your monolith. Monoliths have a single large attack surface. So if an attacker breaks through this single line of defense, they're going to be on the inside of your application with the potential to cause all sorts of havoc. And ultimately, it can be really difficult to leave the monolith, once you're dependent on it. Once you've got customers and a business using it, You have to move very, very carefully if you decide you want to kind of restructure it and replace it with microservices. The organization is going to need to update its technical skills to do that. And the developers are going to need a lot of discipline and commitment to make it through a potentially lengthy conversion process. It could take months or years to convert, an established monolith to microservices. You also need a great testing regime. So if you have a monolith already and you want to convert to microservices, but you don't already have a great testing strategy in place, don't even start to think about converting to microservices. Get your automation, get your testing in place. You're going to really need it during the conversion to make sure that it comes over smoothly and with the fewest amount of problems. So you see, once you are dependent on a monolith, it can be very, very difficult to get away from it. So, if you can go microservices first, obviously, if you think microservices are going to help as well, but if you can go microservices first. And I'll get to the benefits of microservices in just a moment. But first, let's understand what it means to be a microservice. A microservice is a small, independent software process with an independent deployment schedule. Let's dig into that a little bit. Why is it important for it to be small? Having small services minimizes our deployment risk, and it allows for small changes, and small changes can be more frequent, and small changes can be more easily tested. So we can increase our pace of development while also mitigating our deployment risk. How small should a microservice be? Opinions are going to vary wildly on this, I think, but I would say that a microservice should be small enough that you can rewrite it from scratch in a couple of days, if not a couple of weeks. So it can't be big. It's got to be that micro size if you want to call it a microservice. Why is it important for the process to be independent? This is important for fault isolation, which I'm going to talk about in a second. Excuse me. Why is it important for the deployment to be independent? Well, this is so that separate services can have their own release schedules, and it means that faster changing services can have more frequent updates without affecting the rest of the system. And this allows each team to manage the release cycle for their own microservices. And this is something that facilitates independent and scalable teams. Well, we've looked at what a single microservice is. Now let's scale up and understand what it means to be a microservices application. A microservices application is an application composed of many tiny software processes, aka microservices, that work together to build out the functionality of the application. The processes typically communicate via the network. And what a microservices application is really just a special case of a distributed application where the services have been shrunk down to this micro level. So the difference between a monolith and microservices, it's really just that the monolith is just like one large process, and that microservices are many small processes. And you can actually see both here on a spectrum, with the monolith on the extreme left and microservices on the extreme right. I'm showing you this diagram because I want you to know that it's actually not just a choice between monolith and microservices. There's actually many valid points along this spectrum that could work for you and your company. So, you don't necessarily need your microservices to be this kind of pure, as small as possible, single responsibility thing. Like there are alternatives on this spectrum that are maybe not as exhausting as microservices. So, feel free to kind of put yourself anywhere on this spectrum. It is okay, really, from monolith to microservices and anywhere in between. And what I'm really saying is that you can have as many services as you want, and they can be any size that you want. And, it all depends on what you need for your project, for your company. But there are real benefits to steering yourself to the right side of this diagram, to the right side of this spectrum towards microservices, but I'll come to that in a moment. Let's first look at this question, which you might be thinking, why is it that microservices, seem to have suddenly become popular right now? The truth is, distributed applications have been around for many decades. So, building applications this way, it's not really a new thing. So, but why have microservices? Why are they suddenly the hot new thing that's sort of hit the mainstream? Well, firstly, it's because we have these great modern tools available now. And the important thing about the modern tool set that we're using is that it's all automatable. So that's really important, so that we can automate our deployment pipeline and so that we can automate our testing. When we have small services and we're trying to make them as small as possible, we're naturally going to end up with a lot more of them. So we're going to be managing heaps and heaps of services, and we're going to need to lean on our automation to do that. So, this is a crucial thing that we get from modern tools, and it allows small teams to really kind of scale themselves up to larger applications. Now, also what we have today, that we didn't have like maybe 10, 15 years ago, was access to cheap and convenient cloud-based infrastructure. It used to be expensive to run microservices, especially if you had to create a virtual machine for each microservice. But it's not expensive anymore. We have containers now. We can run multiple containers on one VM. We can spread our load across a Kubernetes cluster, which is the way I run my microservices in production. It's really cheap to run microservices these days. And the final thing here is the kind of the DevOps revolution and the rise of infrastructure as code. You guys have probably heard of this sort of thing. Developers are basically managing their own operations now. We've got the tools to do it, and because the services are small, we can manage them. And infrastructure as code, it's turned application deployment into a coding task. And so, individual developers and teams can manage the whole entire life cycle of their microservices for which they're responsible. And small services being managed by separate teams, that's leading to more scalable organizational structures. So microservices are popular now because we've just reached that critical point where, in terms of cost, ease of use, automatability, microservices have become very accessible to mainstream developers. And so naturally, we want to use microservices for all the benefits that they offer. And so that brings me to the benefits of microservices. Some people think that microservices make things complex, and that can be true in a sense. But what I believe is that any application can grow complex. It doesn't really matter how you build it. Eventually, it's destined to be complex as it grows, as it evolves, as you add more features. And the fact is, we shouldn't fear complexity. In fact, I think it's our primary jobs as developers is to manage the complexity that's resulting, from, the problems that we're trying to solve. So what we really need as good developers are better ways of managing complexity. And microservices are an architectural style that helps us manage complexity. And now, even though any microservices application, it is going to grow incredibly complex. And by the way, it doesn't have to start complex. Microservices applications can be started very simply, as I show in my book and some of my other talks. And but any application, microservices application or any application is going to grow very complex over time. And but microservices themselves provide the means for which we can manage that complexity. So if you look at any established microservices application, it's going to look complex and overwhelming. But if you zoom in on any small microservice, at the level of an individual microservice, it's going to be simple and easy to understand. It's going to be small because that's what microservices are supposed to be: small, simple, and understandable. Now, zoom out again and the application's complicated, but zoom in on another area, and the microservice that you're looking at is just going to be a very, very simple server that has, one single responsibility, and it's going to be fairly easy, hopefully, to see what other microservices it talks to. And the important thing is that no matter how big your application grows, you could grow your application to being like a Netflix-sized application. Netflix is built on microservices, but no matter how big it grows, you can still zoom in to the level of the individual microservice and easily understand how it's working. That's the crucial thing here, right? Because no one really understands, say probably very few people anyway at Netflix really understand the totality of how their application works. It's just so vast and so huge. But we can put a microscope on any part of it, and we can understand any part of the details of how that's working. Now, you might say that's all good and good and well for a Netflix-sized application, something that is going to become very large like that. But I would argue that this ability to zoom in and and see the details and just be able to understand any given microservice, I think that's really important for any sized application, and it's something that you just don't get when you're working with a monolith. You just don't get it. With microservices, we get a fine-grained level of control over the application, and this allows for really tight control over security, scalability, deployment, team structure, and so on and so on. Microservices allow us to compartmentalize or componentize our application. Just like how bulkheads are used in a ship to divide the ship or the boat into compartments. And if any one compartment springs a leak, it's isolated. The problem is isolated to that compartment. We do the same thing with microservices. So if a problem happens in a microservice, it could bring that microservice down, but it doesn't necessarily have to cause other microservices to fail, and it doesn't have to cause any disruption to our customers. Unfortunately, monoliths don't work like this. So if something is broken in a monolith, usually it means the whole thing is broken. The whole thing is down. Now, the fact that any given service is small and that we can roll it out independently with the others means that our deployment risk is low. And when we deploy a microservice, what we're risking really is if we break that microservice, we're just going to break a small part of this bigger whole. Whereas if we were deploying a monolith and we broke it, we break the whole thing. Microservices support a scalable team structure. The application can actually be split into many separate code repositories that are managed by different teams, and the teams can be independent of each other. And because they're independent, they can work in parallel without treading on each other's toes. And this allows us to scale up the size of our application and effectively distribute the workload across a growing company. Microservices also support scalable performance. So with the monolith, you only have like the one thing that you can scale really. And it's not very focused. There might only be a small part of this monolith that you want that is the performance problem, only a small part that you want to scale, but instead you have to scale the whole thing, the whole monolith. And that can get very expensive. With microservices, though, there are many more options for scaling. Because the application is already split into components, you can choose to scale only those components that are causing a performance problem. And so our scaling can be very focused, and it allows us to have a much tighter control on our running costs. Elastic scaling also works a lot better with microservices. Because the services are small, we can dynamically spin them up very quickly to meet growing demand or peak demand, and then we can very quickly spin them down again to save money when they're no longer needed. And the last thing here I want to mention, it may not be as obvious as the rest. It's actually one of my favorites. I kind of love this about microservices, that they allow us to isolate our technical debt. So instead of having one huge monolith-sized ball of mud, we can actually divide it into separate islands that are distinctly independent of each other. So, instead of having this big, one big pile of spaghetti code, we can have it all nicely separated out at the application level. And this means that, when we're prototyping or building an MVP, microservices are actually quite good for that, because it allows us to hack out code really quickly. Maybe it's not the best code, the best quality code, but it doesn't matter so much because, the services are small. So later on, they can easily be rewritten. The services are already decoupled from the rest of the system. So we don't mind so much, throwing them away and having to rewrite them. This is called designing for disposability. And it's, we're using microservices basically so that we can rewrite our application over time and incrementally replace it. We're effectively building in an ability to change. So after all this, let's circle back to Node.js. Why should we use Node.js for microservices? I mentioned earlier that we can use any language or technology stack thanks to Docker. To start with JavaScript, it might not be the world's best programming language, but I do believe that it is the world's most practical programming language. You can do almost anything in JavaScript. Using Node.js means we can truly go full stack, and it means we can go anywhere in our tech stack without, changing languages and triggering a context switch. Personally, I use JavaScript or mostly TypeScript these days for front ends, back ends, mobile apps, data analysis, all sorts of stuff. I basically just use it for everything now. Node.js, for its part, it was made for this. In fact, the name Node, it implies that Node.js is intended to be a node in a networked application. Does that make sense? So Node.js is network orientated from the start, and it includes all the fundamental building blocks we need for building networked applications. And the fact that Node.js was built for this kind of thing makes it particularly easy to build microservices in Node.js. Passing data between Node.js microservices is particularly easy. And that's because the de facto standard for communication between services on the internet is JSON. And JSON is something that's built into JavaScript, and indeed it was actually born from JavaScript. So it's really easy to communicate, with data between microservices. And you probably noticed this, Node.js has like a phenomenally large community. And that means there's lots of tools, lots of books, blog posts, tutorials, videos, you name it. There's lots of resources out there that you can learn how to do dev with JavaScript and Node.js. And importantly, there are a lot of people out there that you can lean on when you need help, and the community is more than willing to help you as well. So, whatever problem it is you're trying to get over, reach out to us on Twitter, on GitHub, wherever, wherever you can find other developers. BrisJS, there is a great community out there for JavaScript and Node.js that's just all too willing to help when you need it. Now, before we get into a bit of a code demo, I need to do a quick summary of the basic needs of a single microservice. So that's all we're going to look at tonight in the live demo, is just how to get started with one single microservice. But typically your microservice, it needs some communication facilities. You need to be able to handle requests, make requests to other microservices, process events, emit events. We're just going to be looking at some basic message handling using HTTP requests. And I will be going further with this actually, and talking more about RabbitMQ and asynchronous messages between microservices. But that's going to be in part 3 of this series of talks that I'm doing, which will be on YouTube in about 2 weeks. So check that out later. Also, microservices, need some form of storage, like a database or file storage. I'm not going to be looking at that in the live demo today, but that I do look at how to use a database in development in part 2 of this series of talks. So that's on YouTube already. And in part 3, I'm going to look at how to deploy a database to production. And I might talk a bit more about cloud file storage as well later in that part 3 of this series. So that's more advanced stuff. But it's time to do some coding. Please, if you could start your prayers that this all goes well and nothing fails on me. I have a terminal open already. So I'm gonna make a real simple, I'm gonna bootstrap a real simple microservice from scratch. I mean, there's not going to be much to it, so don't get your hopes up. It's not going to be too exciting, but I really just want to hammer home how simple it is to kind of do this kind of stuff with Node.js. First of all, I'm running Node.js version 14. I'm actually using NVM, which is a really great way to kind of switch between multiple versions of Node.js. So you can actually see I've got Node.js 7 on my machine, which I was using to kind of get a really old project working recently. But mostly I'm on Node.js 14 these days. But look up NVM if you want to be able to switch between versions of Node.js. It's pretty cool. Okay, so I'm gonna make a new directory. I'm actually on Windows 10 here, but I do actually have Linux commands as well. So you'll see me using Linux commands, and that's because I've got Git for Windows installed, which comes with a bunch of those. So you can see here as well, I got some sort of pre-cooked versions of this. So if this all does go horribly wrong and it doesn't work out for me, we can look at a version that I prepared earlier. But I'm gonna make a directory called today. Let's go down there and we'll do npm init-y. So this is bootstrapping a new Node.js project, creating a package.json file. You can see the package.json file there, and you can see it, it's literally the only thing in this directory now. So it's the starting point for a new Node.js project. Any Node.js project, not just a microservice, but that's sort of what I'm intending to build here. I'm going to open this in Visual Studio Code. Just let me bring that down on screen. And the first thing I'm going to do is just create a source code directory. Actually, that's a file. That's not going to help. Let me make sure it's a directory. Okay, so I could just put all the source code in the root directory. I mean, that's a simple way to start as well. But having it all in the source subdirectory is just going to help a little bit when we come to making this work with Docker. So I'm going to show you how to make this work with Docker as well in a moment. So typically, conventionally, a Node.js program starts with an index.js file. That is the typical sort of conventional name for the first file, or the main entry point into a Node.js program. Now, I'm literally just going to start with the simplest possible thing, which is hello world, right? So this is the absolute simplest possible Node.js program. And I can run this under Node just to make sure that it prints hello world. So nothing has gone wrong yet. And typically what you'll do then is to create a start script. And this is just what I just wrote there. So it's just basically the conventional way to start a Node.js program is to run npm start. And that's how you define it. You kind of put your command line that you want to run in your package. This is kind of like a really useful way to work with microservices as well, because when you deploy this microservice to production, you know that you're just going to run npm start, and it doesn't really matter what the main code file is, or if there's any command line arguments that need to be passed in or anything else like that. It's just that every microservice you run that's based on Node.js, if you follow this convention, you just have to run npm start to start it. So that's one thing that's useful. Now, typically at this point, you'd sort of create your Git, your code repository, and you might commit your first, you stub for your microservice or something like that, and push it up to your hosted code repository. I'm not going to worry about any of that today. Just pretend that I am using Git to commit and push changes. Now, what we need here, we need a way to handle requests and a way to make requests. And like I said earlier, Node.js comes with everything you need to build a network-oriented application. So I could get away with just using all the Node.js standard library nuts and bolts to actually do what I need to do. But typically, we don't want to kind of go that low level in the code. And that's why we install something like Express. So I'm going to install Express first. So Express is like the de facto standard framework for building a REST API or a web server in Node.js and JavaScript. There's a whole bunch of other options, but Express is the most popular. And the reason I use it is just because it makes things a little bit simpler. You don't have to kind of do all that kind of nuts and bolts boilerplate code. And Express, you can do really nice kind of routing of HTTP requests and stuff with it. And it's got support for middleware. So it's pretty cool. Now, the other thing we need, so Express will give us the ability to handle requests. We also need to be able to kind of send requests to other microservices. And for that, I'm going to use Axios to make it a little bit simpler, if I can spell it correctly. So I'm just going to install Express and Axios. So these are coming from NPM, the Node.js package repository that's online. If we look at the package file now, you can see under the dependencies section here that we've got a version of Axios installed and a version of Express installed. Now, I've pretty much got everything I need to kind of just do a real basic microservice here. Let me just get rid of that. But what I'm going to do is I'm going to start with the Express Hello World example. This is a really simple way to get started with Express. So I've just got it already open here. Just if you want to find this, just Google express.com, starter Hello World. I'm just going to copy this whole thing. So it's not going to be much more complicated than this. I just add some semicolons there because I prefer to have semicolons. Anyway, but we can just run this. I'm not going to try and modify this. Whenever I start with sample code, I'm going to run it first and make sure it works. So I can run npm start, and that will give me a little web server at localhost 3000. So I can load that up, and you can see here I'm at localhost 3000, and it's printed hello world because that's what this simple Express boilerplate example does. It just prints hello world. Now, what is the next thing I want to do? Now I can add REST APIs here, right? So I've got one for the root. That could potentially kind of serve a static web application if that's what you want, if you weren't hosting that somewhere else, or we can put some here, some kind of query for data, whatever it is, whatever. Say this is a to-do list program. That's a common thing, right? You could get your to-dos through that. Typically, you would, if you were sending a command, so we could send a command to here, like some command. I'll actually trigger this so you can see what it does. So now typically a command would be a HTTP post, but it's a little bit slightly harder to test because I can just test HTTP get from the browser. So I'll just leave it as that. But typically you'd want to make this a post really if it was an actual command. and it's just going to do something, right? This is where you're telling your microservice to do something, and then you've got to send a result, a status to the browser or the client, whatever the client is. So I've got to restart this. This is the pain, right? I've changed some code. I've got to restart it. I'm gonna fix that in just a moment. But let's just restart it for the moment. We can have a look at that. So if I go here, what was it? Do something? No, what did I call it? Oh, some command. Okay, there we go. Let's get the route right. Some command. Now this is just gonna, if I can type it properly, this is just gonna return status OK 200. But if we go back and look at the console here, you can see it's printed it. So we've basically just sent a command to our microservice to do something. And now we can get in here, we can actually do some code here, like we can kind of hit the database, or we can do some transformations on the data, trigger some actions in other microservices, whatever we need to do in this microservice. But it's a bit painful because I have to kind of, like every time I change the code, I have to manually restart it. So let's fix that. Let's put in some support for live reload. And to do that, I typically use a package called NodeMon. But I'm going to install that through npm. But I'm going to save it as a development dependency. So we don't want this. This is for development only, automatic code reloading. We don't want it to have it in production. So we'll save it development only, NodeMon. So NodeMon is like kind of like a drop-in replacement for Node, but it's watching your code files. And as you're changing your code files, it's automatically going to restart the script that it's running. So I don't have to go in there and manually restart my code or restart my microservice after I change my code. It will just happen automatically. Now I could run this from here. Like I said, it's a drop-in replacement for what was it? Drop-in replacement for Node. So I could, oh, sorry, I've got to put the npx command up in front of that to actually execute that locally. So that's running it now. Whenever I change the code, it's going to automatically update. But what I like to do is I have my own convention around this, which I use extensively. And a lot of my sort of the way I have my tools set up works around this. So I add a start dev command. So this is just my own personal convention. This isn't kind of a formal Node.js convention. But what I do is I just get it to run NodeMon for me. So now what I can do is, no matter what project I'm in, I can always run npm run start dev, and that always runs it in live reload for me. And of course, it doesn't matter whether I'm using NodeMon or some other kind of mechanism to do the live reload. All I have to remember is to run npm run start dev. So that's running now automatic reload. Let me just show you how that works. So I've got my code on the right here. I'm going to change this to blah, blah. And you can see that my code on the left here is just restarted automatically. So it's a really cool way to work, just be editing, coding, and having your microservice automatically restart. And I also do this when I'm using Docker Compose to run a complete microservices application on my development PC. I do the same thing. I have NodeMon. I share the code with every container, and I automatically reload them whenever I edit the code for any microservice. And I show how to do that in Talk 2, which is on YouTube. So if you are interested in that kind of live reload for the whole microservices application, check out my YouTube channel. Okay, what else? What's the next bit? Okay, so the next thing that we typically want to do is to be able to get some configuration. And I just want to show you an example of one simple way that you can configure a Node.js microservice, and that's just through environment variables. So for example, say that we want to configure the port to be something other than the default here, which we've set to 3000. We can read that from an environment variable like this, right? So basically we can say if port is not undefined, then let's use port, but we've got to parse it as an integer because it's a port. So we parse it as an integer. Otherwise, if there isn't one, we default to 3000. So now what we can do, you can see here it's serving, it was serving on localhost 3000, but let me just set the environment variable for port to, I don't know, you could set it to port 80. Like normally in production, we set it to port 80, right, which is the default anyway. But if I set that to that, hopefully this is going to actually start on port 4000. So we've got a microservice running now on port 4000. I'll just put that back to what it was though, so I don't confuse myself trying to run this So let's keep that at port 3000 anyway. Now, so what we've got here is we've got the ability to basically handle incoming HTTP requests, and we can, we can translate these as commands for the microservice to do something, or maybe queries for some data to be returned. What we really need, though, is the ability to kind of send these commands and queries to other microservices, and that's what we're going to be using Axios for. So let's get Axios in here now. So Axios is a package we can use to make HTTP requests, and just make them a little bit easier than it would be with the kind of nuts and bolts, boilerplate code we'd have to do with Node.js to do that. Now I've got a URL here that I actually want to get. I'm just going to copy it over. So I'm going to make an Axios request. Let's just get rid of everything there. What am I doing? Axios.get. So we're doing a HTTP GET request, but we're just going to do it to this external service that just returns a list of to-dos. So this is like a public service where you can kind of play around with REST APIs, make requests against this to see what it does and stuff like that. I want you just to pretend here, though, that we're kind of what I'd want this to look like. So this is a to-do list application, right? Is that we're actually going to be making a request to this, I don't know, the to-dos microservice, whatever you want to call it, right? The to-do manager. But I don't have one of those yet. So just for the purpose of the demo, we're going to get some public data, and we'll get the response. And I'm just going to return the response to the client as JSON. So just the data that comes back, we'll return it. So it's like a query. Let's just call this a really imaginative name, like get to-dos. And otherwise, we always have to have error handling just in case something goes wrong, and print out an error message, and return a status code that indicates something failed, 500, for example. So now I've just done that. I wasn't running it. Let's run it. So I've got that running. Now I should be able to come in here and get to-dos, and we should just see that come up in the browser. Let me zoom out a bit so you can see that. So we've got a huge list of a JSON list of to-dos here now. So now, believe it or not, this is like a pretty simple bit of code here. Let's just zoom out a bit so you can see the whole thing. We don't really need the hello world bit of it, so let's just delete that. Believe it or not, this is a great simple starting point for a microservice. Put together really quickly, right? We have the ability to accept to build a REST API to accept queries from other microservices, or to take events or take commands from other microservices. We have the ability to trigger actions or queries on other microservices in our application. We've got our basic communications needs covered here. Now, I would also normally, I wouldn't just be using HTTP requests for communication between microservices. I would also use like an asynchronous message queuing system. Personally, I use RabbitMQ, and that's what I want to talk about a bit more in part 3, coming up in a couple of weeks of this series of talks. So stay tuned for that on YouTube if you want to see some more advanced communication techniques. Now, the last thing I want to do here, though, is kind of build a Docker image out of this and run it. So it's almost like we're almost close to production. Like once you've built your Docker image, then you publish it to your container registry. You're one step short of then deploying that to your Kubernetes cluster and getting your microservice live in production. So we're not going to go that far today, but I will. So it's another one of those things. Keep an eye on YouTube to see some more advanced stuff coming up. Okay, so let's make a Docker file. Before I do this, I'll just show you what version of Docker I'm running. Oh, you know what that is? I restarted my computer and I forgot to restart Docker Desktop. So good thing I checked. Is this thing still starting? Maybe the demo gods aren't going to look friendly on me. Let's restart Docker. Okay, Docker's restarting. Hopefully that's going to work in a moment. In the meantime, let's just make a Docker file, and hopefully Docker will come back up and we can try it out. So conventionally just called Docker file, although usually I would like to separate my Docker files into dev and production versions because I have different needs for each, but we're just keeping it simple today. And we're going to make just the simplest possible Docker file for Node.js. The first thing you do with a Docker file is you say what image, what sort of publicly available image that you want to start this from, you want to base it on. So we're basing it on Node.js 14 and the Alpine distribution of Linux, which is like a cut down distribution of Linux, which is good for production. And it's also it's a lot quicker to download than the bigger version. And then we set our work directory, which is the directory that we're going to be working inside our Docker image as we're creating it. And we're going to copy our package files over to our image. And then we're going to run our npm install. So, my brain is just not working this late at night. What am I doing? Run. Sorry, bear with me. Npm install only production though. So this is where, if you remember, we installed NodeMon. Let's just have another look at the package file. We installed NodeMon as a dev dependency. We only need that for doing live reload in development. We don't need that in production. So that's why we're kind of, we're excluding all the dev dependencies here. We only need the production dependencies. Now we're going to copy our source directory over. Hopefully that's all we need to do. And now we run the command to start the microservice, which is just npm start. To start any Node.js microservice that follows that convention, that's all we need to do. And that means, you know, this one Docker file, like it works for almost any Node.js application, you know, provided you followed these same sort of conventions that I've indicated, like, you know, having your code in a source directory, implementing your npm start command. Now let's see if Docker's come up. I don't know what's going on here with Docker. This was working earlier when I practiced it. Let's try quitting Docker and completely restarting it. Okay, so Docker is restarting, hopefully. So what I'm hoping to do here is literally just do a Docker build. So Docker build in the current directory. Actually, one thing that I'm missing, which I will show you while we're waiting for, hopefully, for Docker to come to life, is that you need a Docker ignore file. Now, this is a bit annoying having to have this really, but it allows you to exclude certain things, which could be quite big. So node modules is one. You know, our node modules are going to be installed explicitly within the Docker image. We don't need to copy them in there. That just wastes time in the build process if we do that. But the other thing that typically, I know I forget to do this, is to add the .git directory. So this isn't a Git repository yet, but typically, you know, if you're working, you'd be working with Git, and you need to kind of exclude that as well. Otherwise, you're sending the complete revision history of your Git project into Docker every time you do a build, which makes it slow down over time. You know, as a project gains history, it's got to copy more and more in. So let's exclude that. Now, do we have a Docker yet? I don't know what's going on here. I bet I need to do a reboot or something like that. So I can't. I'm not going to do this. But what I was going to do is do a Docker build dot and build it to an image. Use Docker image ls to show you that the image was built and it's there, and then do a Docker run. Mapping the port 3000. And then the name of the actual image. So I wasn't going to bother tagging the image, so it would just be like a number like that or something like that, like a random ID that was assigned to the image. So that would run it, and we could see that it was the same microservice but running in a Docker container. Now, what I will say is the Docker's completely failed on me. The demo gods are not smiling on me at the moment. If you want to see this happening, go to my YouTube channel. Where's that? So if you go to the data wrangler, and if you look at this building microservices with Node.js part 1, which is basically the same talk, if you skip all the way to the end and watch the demo there, you'll see what happens when I do the Docker build and Docker run. And so, packaging a Docker image like that of your microservice, it basically combines all your code and all your dependencies in one package that you can use to deploy it. So that's really the benefit that Docker gives us. I mean, it gives us a bunch of benefits, but the primary thing is that it allows us to package our microservice, ready to be deployed to production. Well, that's it for my demo. Sorry, Docker didn't work, but yeah, I probably should have rebooted my laptop just before I started this talk. So I mean, there is a lot more to learn, obviously. This has just been an overview of microservices, and I've shown you how to create a small microservice from scratch, which just has some basic communication facilities so that it can talk to other microservices. There's a lot more to learn. You need to scale up to running multiple microservices in development. I use Docker Compose to do that. You need to be able to test your application. Automated testing is really essential for scaling up with microservices. And you need like a continuous delivery pipeline, and you need a way to deploy your application to production. So, please feel free to check out my book, Bootstrapping Microservices, or check my YouTube channel for the talks that I've got there already, or the talk that I've got coming up in another couple of weeks about deploying to Kubernetes. And please feel free to reach out to me on Twitter or to my email address, which you can see up at the top there. And well, I'll just leave a link up there to my book, and we're going to do a book giveaway, Kevin. So thanks so much, everyone, for listening. And as usual, it's an absolute pleasure and a privilege to be able to talk for BrisJS.
Thank you very much. That was awesome. And we've got a bunch of good questions to go through as well. So this is going to be good. Everyone's definitely taken up my prompt and gotten in on it, which is great.
Cool.
Folks, if you want to do I highly encourage cheating by going back and watching parts of the talk again to get your answer to the book giveaway, so you can go and get the right answers to the question. The question is to win a copy of Ashley's book. Name any of the 3 reasons microservices are popular now, and you have to give me your name and email address in the answer as well. And
there's 2 copies up for grabs as well.
There you go. So be in the pool, and I will pick 2 random lucky people to be able to get it. And that's how that works. So I'll be able to announce it in the next BrisJS. Okie doke. Let's get to the questions. Q&A section. Great. There's a bunch of them. So is it easier to make a cloud-based app in microservices or a node monolith? That was the first thing that was presented when we had Melissa's talk on. Well, so I guess we'll go around and answer that one in a short summary. I think you already have, but
I think, like, people would say that it's serverless is easier, but I don't necessarily think so, because you still have to learn some of the specifics of dealing with your cloud provider and your cloud vendor. Whereas with Node.js, you can just like what I just did is you can bootstrap a monolith or a microservice, just locally on your computer, and you don't have to worry about what's happening in the cloud or deployment or anything like that. So I would say, it depends on what your needs are, obviously, but it's easier to get started locally, if you're not using the cloud. But of course, the cloud's there to be used, and it's we wouldn't have microservices probably if it wasn't for the cloud, because I mean that's what makes it cheap enough to run microservices these days.
Yeah, you used to run a lot of bigger services, even if you split your app. Yeah. So the idea between democratizing the overhead that having to run each server has come down. So that's definitely been an adoption path.
And that's like the first microservices application that I built, which sort of turned out not to be microservices, because Docker had sort of just come out, but we didn't really know about it or know about containers or anything like that. So we were just putting microservices on VMs, but it turned out to be quite expensive. So we packed the microservices full of stuff so that they weren't really. It was like a distributed application of monoliths, basically, in the end.
Yep. a family. Cool. All right, let's get into the first real question. Should JavaScript slash Node should a JavaScript or Node beginner learn to make microservices first after learning monoliths, or both at the same time?
Well, a monolith, you've got to learn to make a monolith anyway, right? Because like there's not too much difference between a monolith and a microservice besides the size. So, you know, definitely when you start learning, you know, don't care about microservices, just learn JavaScript really well and learn how to make a single thing with JavaScript, because it's easy to scale after that. I mean, I think the complexity in microservices is often the deployment pipeline and the complexity in having all these different kind of code repositories with their own deployment pipelines. So that if you take that out of the way, you know, it's just if you know how to build one of these servers, a monolith or a microservice, you know, then you're just building other things like that, basically. So it's not really, I don't think it's really that hard to go from monolith to microservices. Besides all the DevOps stuff is, you know, and learning all the tools is like the hard bit. And that's where serverless can help again. So, you know, if you are set up where you can kind of run serverless, you know, if that's the way you want to run it. I actually don't really want to do that. I don't really find myself wanting to give up servers. Like I don't feel like there's a huge benefit for me. But, you know, if you take all that deployment stuff out of the equation, then it becomes a lot simpler, regardless of whether it's a monolith or microservices. And anyway, if you're just learning, you're not going to be deploying to production. I mean, you can do that. You can, if you follow my book all the way through, you'll get there, right? You'll get to deploying it to production. But you know, feel free to just stay on your local computer. You don't when you're learning, and unless you want to make an actual product and serve it to customers, you don't even need to go to production. So
absolutely,
keep it simple.
Sounds good. Good advice. Cool. Somebody's put in a killer question for you here. What are micro front ends and how do they relate to microservices?
I haven't explored that much myself, but I do have a good Manning book on my bookshelf that I got complimentary from Manning that I do want to read. But a micro front end is I guess it's a similar kind of architectural pattern of microservices, but instead of, you know, breaking up the back end into components, you're breaking up the front end into the components, you know, potentially so that if it must be a huge front end to do that, I would think. But, you know, dividing it up so different teams of developers on the front end can have their own kind of code repositories for parts of the front end. And I don't know any of the technical details of how that fits together. I do want to learn that myself though. Yep,
that's, you know, spot on overview right there. So yeah, the short answer is you're doing the same thing. Like you might be breaking up logical parts of your API in your traditional like server backend style microservice world. You might have like, you know, 3 different API commands that work on a particular service dealing with login and auth, and that's your microservice for login and auth. And you might make another microservice for then, you know, creating a particular piece of content or something like that. You do the same thing on the front end. You start to host your down to the component level, so the component gets served up, and that particular thing and its request can be served up. So the front end portions of that can be served up. So you can have something that does the application frame. That's a microservice that serves that front end piece. The other part can be, you know, your common sidebar, your menu system. That's one microservice that loads that particular thing. So you split up and you've handled the serving in separate applications the same way that you do splitting up and serving all that stuff. So yeah, I should probably actually redo my micro front ends talk for BrisJS instead of having you know, done it for all the historical folks in what was it, Camp.js back in the day.
Oh well, I'd be pretty keen to hear that talk myself. So please do.
See, I usually like to just make sure I try and stay out of the way as much as possible and give you guys the voice. Enough people hear from me doing all the emceeing throughout the night.
Tonight, here's my special guest, myself.
Exactly. I don't know. We'll see. But yeah. So we got one from Greg here. Sometimes the system is designed without consideration to testing it. Does microservices partially or completely resolve this?
I don't think, like, you know, it's okay to start microservices without automated testing. Like you do have to have some form of testing. You do have to have manual testing. You're going to find, if you're going beyond a prototype or an MVP or something like that, you're gonna need automated testing to start managing your application, because that's when it's going to get out of hand. And I would argue that even if you're building a monolith, right, you need automated testing. But if you don't design your application for testing, obviously it's going to be very difficult to test. Like, typically speaking, when you come and look at a legacy monolith or even any kind of legacy application that hasn't been subjected to automated testing, it is going to be very difficult to kind of restructure it and adapt it to automated testing. So, these days you should definitely be thinking ahead about what you're doing with testing and planning for that. I've done a fair bit of test-driven development in the past, so that changes you mentally. I definitely recommend that if people haven't tried test-driven development, to just try it for a while, because it changes your brain wiring so that you think more carefully, or you just understand how to make an app testable. And even if you aren't doing automated testing, like, I do a lot of work on startups where we're kind of prototyping stuff, building MVPs, where, automated testing is something, if the business is successful, that we'll come back and look at later. But, I always design these systems to be testable. And I think microservices are great for that, because, there's multiple different ways you can test them. And I've actually got like that part 2 of my series of talks that I was talking about on YouTube. I've got like a whole section where I talk about testing and, how you do integration testing against microservices, how you do end-to-end testing, what you can use to do contract testing. So there's heaps of ways to test microservices. And but yeah, like having a little bit of an understanding about how you want to test it, and just it really helps the design of for the design of the application to be amenable to testing.
Yeah, and splitting that up as well helps, facilitate other things that you might need. So say you're doing load testing or anything like that, you can hit a particular microservice independently of the others, and all those kinds of things. That gives you options, I think, is also really important to think about. And
that's what you get from microservices, is lots of options for lots of different things. Like, so with testing, obviously, like testing can be easier. Like it can be harder if you're testing a growing application, if it becomes too big to fit on an individual testing PC, but you can, because it's componentized already, you can chop out the things that you're not interested in testing. So you can cut down your application just to test the substrate or whatever, subsystems of it that you want to test. And you can do you can do end-to-end testing of whole microservices applications fairly easily. It's just that you might have to cut them down a bit, when they grow too big to fit, or you might have to test them on some kind of test cluster. But the thing I like about testing microservices is that you can, any particular microservice, you can pull it out, run it by itself against some sort of test framework. I build test beds manually sometimes as well. So it's like, how do you exercise the parts of the microservice that are difficult to exercise through a regular testing framework? You can do things like capturing the output and diffing the output against previous test runs. That's really good, especially if it's like a data-driven microservice or some kind of, data processing thing that has like a data stream or an event stream coming out of it. They're really easy to test, and you don't even have to write code, because you can just kind of, capture the output and diff it against the last working version of it. And if you've got like a microservice that's hooked up to some sort of messaging queue, like I use RabbitMQ, then typically I have a little framework that I kind of connect up to the microservice, and then I can feed in whatever stream of messages I want. I can capture the messages that are coming out, and again I can either use code or just like a diffing tool, really, to kind of check that the output is what's expected. So I think that the componentized nature of a microservices application means you can pull it apart and test things individually, or you can put things together in whatever sets of configurations that you want to do your testing. So I think it really helps for testing.
Yeah, absolutely. Yeah, and you can, like you said, you can run multiple copies of that same microservice and then sort of compare. Like, hey, I introduced some sort of breaking issue. Like, okay, I'll run that and I'll run that. Great, feed it the same thing. What happens? So yeah, I think you definitely hit the nail on the head there. The next question here is are Docker containers running a service, so in brackets Node, and serverless cloud functions both considered to be microservice? What's the difference?
No, I don't think so. I don't think serverless, they're not considered microservices. So serverless typically is just one function, or like, it would be, a microservice would typically be composed of multiple functions.
Yep.
So you know, like a serverless function is just one part of a microservice, really.
Yep.
It's
cloud services, microservices, and then cloud functions.
You know, it all falls on a spectrum, though, doesn't it? It's like
yeah,
you know, like the simple responsibility. Sorry, the single responsibility principle applies here. Like you know, a function is going to do one thing well, but it's going to be a really small thing that it does. A microservice is going to be a little bit bigger than that, but again, it's, you know, it does one thing and one thing really well. So, you know, they have a commonality in that sense.
Mm-hmm. Cool. Do you usually structure your Node backend apps in a feature-based in feature-based folders or MVC folder pattern in your microservices?
Definitely not MVC. Features, maybe a little bit features, but you know, typically what I do when I'm building a microservices application is I use domain-driven design. So that's a book by Evans, I think, from about 2003, which has sort of become a little bit popular again recently with microservices. Like it's a way of designing applications that just fits really well with microservices. And it's a way of like modeling the business and the business processes and the entities and, you know, the communications between them that aligns really well with, you know, like it's almost like a microservices application falls out of that design. So I don't normally look at features. I look at the business and I kind of work backwards from there, try to understand the business, model the business, and then, you know, I don't know, I guess it's just an intuitive feeling for, like, you know, what would make a good microservice, and you never get it right the first time anyway. Like, it's the important thing with microservices is they give you this ability to evolve and change over time. So you know, you can start with this kind of design, but then, you know, kind of evolve it incrementally as you go.
Yeah. Which question's next? Here we go. I lost my place. I found that some cloud providers block or make it hard to use Docker Compose in some parts of their platforms.
Yep.
Do you have this problem as well?
So I don't use Docker Compose for production. This is part of that talk too, like where I basically talk about, I give a demo of using Docker Compose with multiple microservices. But I use Kubernetes for production because Kubernetes is really the go-to solution, you know, for scalable distributed applications. Kubernetes is like an operating system for multiple computers. It kind of, you can have any number of virtual machines under Kubernetes, and you just say, like, you just plonk. It's a bit like serverless in a way, but it's like almost like computerless. So it's like, you know, somewhere under this cluster is a you know, possibly a large number of computers. You know, Kubernetes out of the box supports up to 5,000 nodes in its cluster, and you just send a container at it. You send a Docker image at it and say, run this thing, and it'll just run it wherever there's capacity, right? So I actually kind of think of Kubernetes in a way as serverless, although not completely, because I went in there and I set it all up, you know, like, or at least, you know, if I wasn't working for a startup, I might have an operations team that did that for me. But what was I saying? So you know, you're just throwing containers at Kubernetes. I almost used Docker Compose for production back when I thought Kubernetes was going to be too complicated for me to learn. I sort of pushed through that, and I'm glad I did, because Kubernetes is fantastic, and I'm so glad I'm using it. Yeah, Docker Compose, like to get that to run, like I mean, I think Docker, the company, has like Docker Swarm or something where you can kind of deploy your Docker Compose, but that's the kind of thing I'm trying to avoid. I'm trying to avoid that vendor lock-in, so I didn't want to do that. And then I did try instancing a VM and installing Docker and Docker Compose and all that on it, and then just running an application that way. But it just feels wrong. Whereas Kubernetes just had this beautiful automatable API that allows you to lob containers at it basically and say, you know, put this somewhere where there's resources to run it. And actually, I'd love to be able to use Kubernetes in development, but the problem with that is it's quite difficult because I mean, you could run something like Minikube, or there's a couple of smaller versions of Kubernetes, and also if you install Docker Desktop for Windows, it actually comes with Kubernetes. So I did try running Kubernetes on my laptop and almost killed it. So it's got Kubernetes is kind of heavyweight, right? Like, so I decided not to use that. And then like setting it up from scratch, if you want to set up a Kubernetes, simulate a Kubernetes cluster, because obviously you can't run multiple computers on a single computer. If you want to simulate that on your dev machine, like that's a complicated thing to do. So I don't recommend, you know, trying to set up Kubernetes yourself on anything. But if you set up Kubernetes through a cloud vendor, like it's super easy. Like on Azure, it's just a couple of clicks. It's a little bit more complicated on AWS, and I think it's probably pretty easy on Google as well, seeing as that they invented it. So Kubernetes is great and easy to set up in production, really difficult to set up in development, but Docker Compose is like really super easy to use in development, and just it saves you a lot of time, starting up all your services and building them and running and constantly restarting them and stuff like that. And it aggregates all the logging output as well, so you can see the output of all the microservices you're running locally. And it's a great way also as like as a team lead or something like that. It's a great way to distribute configurations of your application to your team members. So like I said before, if you want to test a big microservices application, you've got to cut it down. You can have multiple like Docker Compose files in your code repo for different configurations of your application for working on different areas of it or testing different aspects of it, that kind of thing. So I just say Docker Compose for development, Kubernetes for production until we have some better tools that maybe replace those.
Makes sense. Cool. Greg Hicks was saying Minikube is good desktop for Kubernetes.
Yeah,
good for desktop Kubernetes. Minikube.
Cool. That's how I started learning Kubernetes. So I highly recommend people having a play with that. Or there's a couple of alternatives now as well for like cut down Kubernetes distributions that you can run on a single computer.
Cool. Do you ever reach for gRPC for your inter-service communications, and what's your reasoning?
I don't, but I've heard it's good. I mean, it's highly performance orientated. Possibly Kubernetes actually uses it under the hood because they both come out of Google. I'm not sure about that though. I typically I just use JSON messages because I haven't need to push a system so hard that I need kind of an optimized binary message format between my services. So I stick to plain old JSON usually, and it works pretty well. Yeah,
and it depends. Like you may have like a service broker or a workflow engine of some description that talks gRPC and uses that for its orchestration. So you may end up doing that as part of your architecture. But yeah, I guess that goes back to your architectural design, folks. It's down to how do you want to get your services talking, and what are the benefits, pros and cons of either. Do you need the orchestration? If so, yeah, maybe you might reach for something like that, and you might introduce something like ZB or whatever if you want to have workflow based orchestration. But yeah, it depends. If you're just you want your services to communicate over their own APIs, you don't need to have a separate inter-service communication versus your own public API. You can consume your own dog food and have it consume its own APIs between each service. So there's different ways to approach that kind of thing as well. But yeah, that's a good question. And it's definitely enough for another talk if anyone wants to volunteer that one. So yeah, I think we've had a big list of reasonable talks here actually. Cool. Somebody's put in another question for you here. This is a good one. Cool. Favorite front end, React, Angular, or Vue?
I'm a React guy. I see the benefits of them all. I used to use Angular before, or when it was version 1. But when it came time to kind of really change, to relearn Angular to kind of move on with that, I had to play with React and just found that I really enjoyed using React and coding in that. And I love the React render function. Maybe that's because I'm an old game dev guy, and the core thing is the render function, the render loop in the game. So maybe it's nostalgic for me for some reason.
Yeah, I had a similar path. Started on Angular 1 series, moved to React. And I've played with Vue a lot, and I really enjoy Vue. So I think it's got a lot of merit. It's very underrated, actually. It's super popular, actually. It's very, very good. But yeah, honestly, whatever you like, what works for you guys. They've all got some amazing benefits. So
I think we're privileged to live in this age where we've got these great web development frameworks, right in front of us, with lots of resources on how to learn them, lots of people to talk to help figure stuff out. Because I've been a developer for over 20 years, and I sort of tried web development various times, like in Perl using like CGI scripts like back in the day, and it was awful. I tried using jQuery years ago and I hated that. And then when I came back to web development, within the last 8 years or so, just like spoiled for choice, really, starting with Angular, and then some of the things that have sort of, I think Angular really paved the way for some of these modern frameworks.
Yeah, I got a lot of really incredible adoption early on as well. So yeah, it did a lot for everyone. There's another 4 here. We're getting through it. Do you think runtimes in other languages or a new JS runtime that scale? Hang on, I need to get the sentence structure right. Do you think runtimes in other languages, I assume there's a comma, or a new JS runtime, so an alternative JS runtime, comma, that scale and fault isolate better than Node, might see services move back left on the spectrum? So I'm assuming back away from microservices.
I don't see that happening. I think there's a at the moment microservices are really popular. That's why we're talking a lot about them, and only because we can. We've sort of got to that point now where we've got the tools and the cloud and everything that we need to actually be able to effectively and cheaply use microservices. But over time, it's going to be less focus on microservices, and you can be wherever you want on the spectrum. You can have a monolith and 10 microservices, or you can have two fat services, or 10 fat services, whatever combination on the spectrum you want. And I don't think it's necessarily an issue, and I think that's the reality of it as well. I get to work on a lot of greenfield projects, so I get to make sort of what I call the developer's utopia of microservices in some of my projects. But I've worked at plenty of companies on legacy projects as well. I know the reality can be really different. And also I like to say that if you're a company that's trying to transition from a monolith or something that's not microservices to something that is, you don't necessarily need to push all the way to kind of pure microservices. I think as you're making that transition along the spectrum, you're getting a return on your investment, but eventually the return on the investment starts to run out, and it may not be worth trying to push all the way to the end, because it requires a lot of dedication and commitment and discipline from the developers.
Yeah, and it's also worth remembering that microservices is not just about multi-threading. It's not just about the stability of one core thread of processing or one core application.
I think it's about having
you're able to distribute more. Yeah,
I think it's about having the right granularity, really, that works for you, and that could be a monolith, or it could be microservices, or somewhere in between. But having the granularity where you can control the security and the scalability, and divide it up efficiently among your team, and all the things that might be important to you, that you have the right level of granularity. I actually want to learn. I was listening to a podcast the other day where they're talking about Erlang. Have you heard of that? So that's actually the programming language that probably not as many people have heard of, but it was actually used to build RabbitMQ. And it comes from a telecoms company. I can't remember which one, but they used it to make these kind of distributed telecommunications network for telephone switching and stuff like that. And so it's almost got the microservices model built into it. It's called like actors or something like that, right? But I do think there's room for a new language in the future that really supports the distributed model of computing better. I think Go is probably quite good at that, and that's something that's sort of on my on my list of things to look at in the future, but I haven't explored it yet.
Sounds good. What's your preferred data layer for Node microservices?
Data layer? What are the options? Is it multiple choice?
No, it's not. You get to choose.
I'd just like to say that JSON is the way to go for me. That's one of the things that I loved about sort of moving most of my development, at least to JavaScript, is that it's got the kind of the data definition language built into it. It always annoyed me back when I was working with C++ and later C# that you had to always write all this custom serialization code, and you have to kind of then run this process to map your data into your objects or your classes, whereas in JavaScript it's just like completely automatic. I'm a bit of a data nerd, obviously, and I just love the fluidity of being able to work with JavaScript and JSON data like sort of built into the language like that.
Yeah, they might be referring to the persistent storage, I guess, sitting behind all the services. Yeah, that might be my interpretation. I'm not sure if I'm right there or not.
My go-to database is MongoDB, so that's what I cover in my book. But you're using Docker, so it's really easy to bring in any kind of database or any kind of other server, third-party server that you need into your application. So that's one of the things to love about Docker as well, is that you've got this whole world of like public, almost like packages, but they're Docker images. But I kind of like to think of Docker as the universal package manager. Like, it's the one thing that you can package up any language, any tech stack, and then, within an instant have that thing running like in either on your development PC or, in your production cluster.
Mm-hmm. I just saw that Robert Ellen had actually posted that the one about other runtimes or other languages that fault isolate. So he was just saying, I use Node and Erlang Elixir, and the scalability and fault tolerance is a very interesting trade-off. So yeah, there's that's the context, I think, of that other question there as well. I think that does go back to what we were saying. There's
Yep.
definitely languages and frameworks and tools that particularly lean towards one way or another, and I guess it depends on your problem, right? Like,
yep,
really goes across what you're really trying to solve.
Yep.
If you want to invest a lot in that, in that particular fault tolerance or scalability aspect, you got to see where you're going.
Well, there's nothing I know of that really kind of tackles the whole problem for you. Like Erlang, there's something I'd like to learn more about, but it seems like it kind of tackles the whole distributed problem for you. And I don't think there's any other language or framework kind of that really does that. Like at the moment, it's pretty much, you're using Docker, so you can mix and match your languages, your databases, your tech stacks, but there's no kind of overarching like thing that makes the whole thing easier. But I can foresee like a day when we have that kind of language again, like that, you're not focusing really on all the infrastructure and like Kubernetes does that to an extent where it's like you don't really care what computer it runs on as long as it runs somewhere where there's resources to run it. But it would be nice if that was I think it will be a bigger thing in the future where it's like it's almost like the promise of serverless, but I think I would like serverless more if I controlled the servers that it runs on, because it's not really serverless. It's like it's just someone else is managing the servers for you. And
someone else's computer.
And you can do that kind of thing with Kubernetes as well. It's just there isn't that kind of I do think we need some sort of overarching distributed paradigm. I don't know what that's going to be.
Yeah, and I think part of the choice between a lot of what you're doing here and going with like cloud functions and stuff like that is, whether or not you want that granularity in your scalability as well, or whether or not you just find it easier to get started. Maybe you don't want to have to bother with a lot of the tooling and managing and the ops side of the microservices side of things. Maybe you just wanted to throw it at Azure and get that thing going out of your GitHub repo.
Yep.
That's totally doable. And there's other things that help you do that with microservices as well. And I think it depends where you're at in your journey and what you want to build and those kinds of things. There's definitely no one size fits all.
My journey went the way it was, a lot because I didn't want to be locked into any particular vendor. So that's why, I love Docker and Kubernetes, because it's, it frees you. So recently we made use of this. So I've recently ported an application from Azure to running on AWS, and all it required was figuring out how to boot up a Kubernetes cluster on AWS. And then we ran the deployment scripts, and the application was replicated there. So, it's great to have that freedom, and that's the kind of one of the things that worries me a little bit about serverless, is that if you have to implement your function in a particular way, then you can't port it to any other cloud provider. Maybe that's probably wrong. I don't know if there's a standard for that. I don't know enough about it, but that's the kind of thing I'm worried about, though, is kind of vendor lock-in and not having freedom to move, when there's better options or cheaper options.
That'll be the next talk. Cool. So Nick's got us
between the microservice and best practices, etc.
Hang on, sorry, I lost audio there for a second.
I think I lost my audio. Hang on.
Am I back?
Yep, sounds good.
Awesome. Sorry about that.
What was that question?
I'll start again. Would you cover logging between the microservice? What's best practice, etc.?
Yeah, so I actually have a few ideas on this. I'm actually experimenting with using a tool called Loki at the moment, which it's really simple to get started with. You just install, I mean, if you want to set it up manually, you can, but I set it up in a really automated way, sort of cloud-based way, really, where I've installed this thing called Grafana Cloud Agent into my Kubernetes clusters, and it basically sucks out all the logs from all the Docker containers and forwards them wherever you want. But I just forward it to a Grafana Cloud instance, which allows me to kind of ingest the logs and search them. So that's been great. I've just been using it in the last few months on a few projects, just because it's so easy to set up. And before that, I was setting up kind of some of these Prometheus instances manually in my cluster, and then kind of setting up a Prometheus server somewhere else to actually ingest logs, and then a Grafana dashboard instance to be able to, it's kind of complicated if you set it up yourself. But Grafana Cloud have like a free tier, so I've been playing around with using that, and it's pretty cool. I also kind of have my own solution for this. If you look at my blog, The Data Wrangler, there's a blog post up from probably about 6 or 7 months ago now, where I'm talking about how to do it yourself, like where basically you're deploying what's called a daemon set into Kubernetes, and basically you're able to deploy a container that runs on every node in the cluster and be able to access, give it permissions to access the local log files, and then you can send those log files wherever you want. I tried, for my startup, I tried sending them to our Slack workspace, so we get all the logs there, but it just turned into a massive mess, so I don't recommend doing that. But I mean, it's really simple to build a fairly simple log viewer as well. So but don't do it yourself. You use something like Loki. Loki's really promising. It's fairly new. Before that, you would have used like FluentD and forwarded your logs to Elasticsearch and used the Kibana dashboard. But that's kind of a bit more painful to set up and fairly resource intensive as well. Like I actually installed that into a cluster once and killed the product because I didn't have enough kind of CPU basically to run that. So but yeah, Loki plus Grafana Cloud. I think that's the best solution. The quickest solution anyway at the moment.
Sure.
I will say there's a gap in the market here for something that's really lightweight, really easy to install, and really easy to use. So like, I don't think anything really, like, I don't love any of the solutions that are currently out there for aggregated logging for microservices. I mean, it's great if you're doing it locally. If you're running on your development PC, use Docker Compose, and then that automatically aggregates all your logs from all your microservices that you've got running locally. So that's fine for development. And then you can kind of pipe the output in the standard error to a file as well using the T command. I often do that. So that then you can open up the log file in Visual Studio Code and you can kind of check it for errors and search for stuff. And it makes it a bit easier to work with logs in development.
Yeah. So Nick was just saying, he was pointing out to me that I missed the second half of his question because they're posted as two. He wanted to focus on how to handle, so trace which service has the error. So like if you've got microservices coming through, so I presume like it's tagged between all your, in your Grafana logging that you've talked about.
You can tag it with whatever you want. So I mean, basically the configuration for the agent that you're running in your cluster, you can produce kind of tags for the outgoing logs there. And I think you can have sort of rules and stuff applied to it, as it gets ingested into Grafana Cloud as well. What else was I going to say? I mean, you can have whatever tags you want on it, really. Yeah.
So I mean, I'm not sure, certainly not off the top of my head, if there's anything that sort of lets you stack trace through multiple server calls.
No, there definitely is. I'm just trying to remember the names of them. I definitely referenced one of them. It might be called Zipkin in my book. I haven't used it, but it looks, I've had a play with it. It looks pretty cool. And I did notice there's a couple of other things for monitoring. If you look on the Cloud Native Computing Foundation website, that's the foundation that's responsible for Kubernetes and Prometheus and a whole bunch of other great open source tools for doing cloud native development. They have got like maybe 2 solutions that I hadn't heard of that I kind of just noticed recently. I think one of them is called Jaeger, and the other one might be called like open tracing or something like that. And so these are the things that can actually, like it almost looks like you're looking at the performance tab in the browser, right? But you're, where you see all the bars of the things being downloaded. It's a bit like that, but it's showing you kind of how stuff is going through your cluster and how requests are being passed through your cluster. So, typically to do, I don't know how they do it, but typically to do something like this, you need like a correlation ID. So when you get a request coming in from outside the browser, you tag it with some sort of GUID, and then you attach that to the headers of the request or the message, the payload of the message as the message passes through the system. And so, and if that spawns any other messages or events or whatever in the system, you also kind of tag it. So you've got, if you're, and you're just producing like augmented data for your logging then. And so if you're using something like Grafana Cloud, you can then go and search on that correlation ID. So if you find a particular error or something like that, you look at its properties, you look at the correlation ID, and then you search on that to find out everywhere else that's related to that. So it's not difficult. It's not difficult to kind of, trace requests and messages, through a complex application like this. But, and unless you've got like an automated tool doing it, it does require some, discipline to get set up with. It can really help if you have, like for my startup, I have a little kind of framework called Micro. It's kind of like Express, but for, it makes it easier for me to build microservices. And it's got under the hood, it's got automatic support for RabbitMQ and a whole bunch of other things that I use, like, attaching correlation IDs. That's the kind of thing that you can kind of put in your shared microservice library. And then you don't have to kind of go coding it into every single microservice you ever write.
Yeah, back in the day when we were sort of trying to extend that logging in our stack as well, being quite a deep stack, it goes front end and then APIs, then workflow engines, then services down to hardware. Then we ended up having correlation IDs passed through various headers and things like that, and forwarded as you go down the stack as well. So the idea then is when you aggregate all your logs, then you can kind of trace on the same correlation ID and you see the entire stack posted down, and then you can kind of see the whole thing play out. So I think there's lots of different sort of ways to approach that. But I couldn't come up with it off the top of my head in terms of any sort of out of the box kind of stuff there, but great tips there. And I'll link in what I find from the Cloud Native Foundation as well, and put it in the chat, or perhaps if you end up stumbling across it again, Ashley, just tweet it out to BrisJS and I'll retweet it for everyone's benefit.
Okay, cool.
That's good. And the last post here is just a thank you for all the answering of the questions. Thank you. Thank you for giving us questions, guys.
Thank you for listening and asking questions.
That's it. That's all great. So thanks so much for your time. Awesome. Fantastic. I appreciate it. Appreciate all our speakers at BrisJS, and thanks for all the Q&A time, spending all the time with us tonight, and to our wonderful audience for having gone through this wonderful journey tonight, going in depth with how we host things and how we can get our node code out there. So it's been fantastic. So thank you very much, everyone. And and thanks to our speakers. And I will just throw up my last slide because there might be some useful links on there. So I'll do that, and I got to get this down to be smoother, but it's Zoom. All right, that's the one, everyone. So let me click my buttons. There we go. Done. This is thank you for joining us. It's been BrisJS, and I hope you've had a lot of you've had a lot of useful takeaways from this. Thank you to our audience for being so interactive tonight. Really appreciate that. Do remember, guys, there's a book to be had. Make sure you hop on that poll and answer those questions. Just one question. Any of the points from that particular question would be fantastic, and then you will be in the running, and then I will run random number generator over it, and 2 of those lucky options will be picked. So thanks very much. Get some free stuff. It's the door prize is there for a reason, and we love to support our audience members and everyone. So thank you again. If you need to get in touch with me, here's some details on the screen. If you please just hit up at BrisJS. My email is always open as well. If you need any support trying to get a talk up, please feel free to volunteer anytime. We definitely want to hear what you've got to say. And the Brisbane JavaScript is a platform that's here for you. Everyone's welcome. If you want to be that face that helps inspire somebody else, that would be amazing. And I know everyone would appreciate it. So thanks very much. I'm going to leave you with that, and enjoy the rest of your evening, and good night. See you next month.